In this experiment, we're going to do a lot of different types of chemical reactions. And as I go through them, be sure to note the indications that a chemical reaction has occurred. And these were given in your notes. And for example, color change is one of our indications we will be looking for. But there are some others, so refer to your notes. Our first reaction is our combination reaction, and the combination reaction will be done in a porcelain crucible, and that's because we're going to be heating our reactants. So this is a crucible, and we're going to weigh it first, and so note this mass. This is its mass when it's empty. Next, we put some copper into our crucible and weigh it, so note this mass. This is the mass of the crucible with the copper. This is a close-up of our copper. You see that it's kind of a gauze, it's wiry. It has lots of surface area so that there's a lot of contact with the copper and the molecules that are in the air. We have it set up in this triangle so that we can heat it from below. As we know, heating will speed up the reaction. This is what it looks like when we heat it. The crucible is down in the flame. That's why we had to use a porcelain crucible so it wouldn't melt. It's very, very hot. In fact, it will be kind of glowing orange by some of the end of it. After we're done with this, we have to really let it cool. This is what it looks like inside after the heating. Let's compare that to what it looked like before. And we can see quite a bit of change there. Now we are weighing the crucible with the material inside, and be sure to write this one on your report sheet. Next is the decomposition reaction. And for the decomposition reaction, we put a solution of hydrogen peroxide into a test tube. Now, hydrogen peroxide is something you probably have at home. It's a solution of it. It looks like water. So it is colorless, no color, and clear, meaning you can see through it. Manganese 4 oxide is a catalyst. And this material is like a very fine sand, and it's charcoal in color. It looks like sand. So because it is very fine and dark in color, when we put it into our test tube, the whole thing is going to turn gray. And that gray is not a color change. It is just the color of the MnO2 catalyst. This is what it looks like when we put the catalyst into the hydrogen peroxide. Now, I warned you it would turn gray, but I want you to notice it kind of has some foam at the top. And if you look down in here, you can see white bubbles. Another thing that you can't see here is that this test tube warms up slightly when you add that catalyst. Our next reaction is the single replacement reaction. And for this one, we set up two test tubes, and they're kind of opposites. One of them has solid copper in the bottom, and that's what you see down here. And it has a zinc sulfate solution above. And this zinc sulfate solution is clear, you can see through it, and colorless. It looks like water. On the other test tube, we have a piece of zinc. And that piece of zinc is gray. It has a bubble under it, so ignore that part. But the solution above is copper sulfate. And as you can see, copper sulfate is clear. You can see through it, but it has a color. It's blue. So kind of note those colors. Because of the way these test tubes were set up, where they're kind of opposites, only one of them is going to react, because in a single replacement reaction, only a more active metal can replace a less active metal. And either copper is more active than zinc, and it can replace zinc, or the other way around. So you need to figure out which one of these test tubes is reacting, and it's the one that's more obvious. On some of these you have a little bit of reflection and stuff, and it's a little hard to see what's going on, but one should be obviously changing compared to the other. So on this one, I'll let you see the before in a minute, but I wanted to tell you something that you observe with this one, and that is that at the top, it was hard to get a picture of it. It had a little piece of floating orange shiny stuff up there. Let's compare the colors to before. Here you can see the colors of the solutions before and after, and like I said, only one of these is really changing. Because it's really hard to see the color of the metal when it's down in the test tube, I pulled some out so you could see the before and after for the metal. Of course, the copper one is the orange one, kind of like a new penny, and the zinc are these over here, and you can see the before and after and what's happening to those. Next, for our double replacement reactions, we're actually doing a whole lot of reactions on a spot plate. And the way the spot plate works is that for each spot, we have two solutions. Like for this spot, I use this H2SO4, which is sulfuric acid, and this barium nitrate. And I just add a few drops of each solution. Now, all of these solutions are clear. You can see through them, not cloudy, and they're colorless, so they don't have a color to them. That is before we mix them. Some of them, when you mix them, get cloudy, and you should know what's going on with that. Now let's talk about what's going on with these compounds on the right. You notice in green I marked all of them are nitrates. They all have nitrate in them. And nitrate is a spectator ion in aqueous solutions. It does not react. So what we're really doing is seeing what happens with the cation or the positive ion in these compounds. For example, in the top one, we are seeing what is happening with the barium ion. The barium ion is a positive ion, so it is a cation. And like I said, what we're doing is we're seeing how the barium ion reacts with each of these reagents and if it reacts with them at all. And so what we're going to do for our unknown is we're going to, it contains a cation, and it could be one of the ones above, the barium, calcium, magnesium, or strontium cation. And we're going to see how it reacts with all four of the reagents at the top. And from that you can identify your unknown. Lastly, I have a few hints on number 1 on your report sheet, A, B, and C. Those reactions are in the notes. Be sure that you write balanced chemical equations and show the state symbols. The state symbols are the symbols like this. Okay. Also on D, one of those does not react. For one of those reactions, you should just write no reaction and don't write the products. And that will save you some time, figuring out what the products would be when it doesn't even react. So you don't want to write products if it doesn't react. How do you know it doesn't react? Well, you'll look at your spot plate. All 3 of those reactions are found on your spot plate. And so what you'll do is you'll find the reactions, and I'm just randomly choosing some, and see if when you mix those reactants, if it reacted or not. So find the one that didn't react and just write the arrow and no reaction for it. And those are all of my hints and all of the data that you need to finish your report sheet.